Okay, so I just want to quickly go over Chapter 5 of the Cambridge Exam Board Additional IGCSE Maths, and this is everything you need to know. So as you can see, I've copied and pasted this from the specification from the website. Chapter 5, Factors of Polynomials, there's only 3 things you need to know. Know and use the remainder and the factor theorems, both of which are intertwined and relatively similar. Find factors of polynomials and solve cubic equations. Okay, and we're also going to see that these two are also quite linked to each other, and they kind of come in hand. They come hand in hand. So cubic equations are just going to be in the form ax cubed plus bx squared plus cx plus d, where a, b, and c and d are all real numbers, and a does not equal to 0. Okay, so that's the highest degree equation we're going to be solving in these papers. Okay, so let's have a look now. The remainder theorem and the factor theorem. So the remainder theorem states that if a polynomial f of x is divided by x minus a, the remainder is f of a. Okay, so I'm just going to rewrite what they have here because this can be quite confusing when you first see it. So if we take a polynomial f of x and we divide this by x minus a, we're going to get some value. It's going to be a function of x, so we'll call it a, plus the remainder, right? And the remainder could be 0, but it might not be. All the remainder theorem is saying is that this remainder is equal to f of a. That's it. Okay, so this remainder is equal to f of a. I'm not going to show a proof, but if you do want a proof, I may do it in another video, or I'll just link another video in the description below. You don't need to know the proof, but you need to know this theorem. You need to, okay, you don't need to know this, don't need to know the other thing, but you need to know this, well, I say you don't need to know this, it's not a problem if you do know it, but you need to know this theorem, you need to know the factor theorem. You will not get any of these in the formula booklet, okay? So the factor theorem is just another theorem stating that a polynomial f of x has factor f x minus a if and only if f of a equals to 0. So if a polynomial f of x has factor x minus a, we know that x minus a times by something is equal to f of x, right? That's a definition of something being a factor. 2 is a factor of 4, so we know 2 times something is equal to 4. X minus a is a factor of f of x, so x minus a times by something is equal to f of x. This is the case if and only if f of a equals to 0. Okay. Again, I'm not going to give a proof, but I will put a proof in the description if you want to see one. You have to know the factor theorem, you have to know the remainder theorem. They will not be in the formula booklet. Okay, so let's see them in action. You're given that f of x is this polynomial here. It's a quintic polynomial, it's degree 5. Don't worry, we won't have to solve it. But we know that when it's divided by x minus 2, the remainder is 18. So by the remainder theorem, if x minus a divides our polynomial f of x, we know that the remainder is going to be equal to f of a. So in this case, the remainder is going to be equal to 18. So we know that f of 2, in this case, our a value is 2, equals to 2 to the power 5 plus 2k minus 20, and that equals to 18 by the remainder theorem. And once you solve that, you should see that you get k equal to 3, and it's always good practice to then resubstitute that back in. So we know that f of x is equal to x to the power 5 plus 3x minus 20, and that's it. 3 marks, 3 nice easy marks. Next one, g of x is this polynomial, degree 3, this is a cubic. Use the factor theorem to show that x plus 3 is a factor of g of x. Well, the factor theorem states that if x plus 3 is a factor, the factor theorem states that x plus 3 is a factor if and only if f of minus 3 equals to 0. Okay, if I just put a reminder, x plus a is a factor if, x minus a is a factor if and only if f of a equals to 0. If we just compare the values of a and 3 here, we see that x plus 3 is a factor if and only if minus 3, f of minus 3 equals to 0. Okay, so we know when we sub in minus 3, we make that equal to 0. We can solve, we can show that it's a factor. Okay. Excuse me, if we sub in minus 3 and it becomes 0, we know that x plus 3 is a factor. Okay, so let's see. I should have been saying g here this whole time. This is g of x. So g of minus 3 equals 4 times by minus 3 cubed minus 8 times by minus 3 squared minus 35 times by minus 3 plus 75. And we find that if you calculate that turns out to be 0. Therefore, x plus 3 is a factor by the factor theorem. And that's it. 2 marks there. Okay, let's have a look at our next point. So this is what I deem to be a more tricky question, but again, it's not even that tricky. Is when they give you 2 pieces of information, 2 unknowns, and you have to solve for both unknowns. So in this scenario, we're going to be using simultaneous equations. It's a good idea to keep in the back of your head. Count how many unknowns they give you, count how many pieces of information they give you, and then try and work with that information. If there's 3 unknowns and 3 pieces of information, we may have, you know, triple simultaneous equations, if you like, 3 linear equations with 3 unknowns. Now we have 2 unknowns, 2 equations. It's very likely we're going to be solving some simultaneous equations here. So when f of x is divided by 2x minus 1, the remainder is minus 5. By the remainder theorem, we know if f of x is divided by 2x minus 1, then the remainder f of a half is equal to minus 5. So we know that 2 times by half cubed plus a times by half squared plus b times by half minus 6 equals minus 5. Okay, and we should see that we get a quarter a plus a half b equals 3/4. And the second one now, when f of x is divided by x plus 2, there is no remainder, so x plus 2 is a factor. If something can be divided without a remainder, that's the definition of it being a factor. So we know that f of minus 2 equals to 0 by the factor theorem. You can write this if you want here by the remainder theorem, and you can write here as well by the factor theorem. We know that f of minus 2 equals to 0. Okay, so we know that 2 times by minus 2 cubed plus a times by minus 2 squared plus b times by minus 2 minus 6 equals 0, which leads to our second linear equation, 4a minus 2b equals to 22. 2 equations, 2 unknowns. We can solve this by simultaneous equations, and you find that a is equal to 5 and b is equal to -1. Okay, and again, always good practice to substitute it back into our function here. 2x cubed plus 5x squared minus x minus 6. Nice easy 6 marks there. Let's move on now. Let's have a look at the second 2 points that we need to know how to do. Solve cubic equations and find factors of polynomials. Okay, so we can be asked, we can just be given a cubic and we can just be simply asked to solve it. Okay, let's have a discussion now about what we're going to do to solve this. Let's think about what we do to solve a quadratic. When we solve a quadratic, ax squared plus bx plus c, we factorize it into 2 brackets, right? Something x plus something, plus or minus something, and then something x plus or minus something here as well. Okay, we're going to have the same situation happen here. Okay, and we are probably going to have 3 brackets. Yeah, it can be a case that we have two brackets. I'm going to have a quadratic and then a linear, but my explanation will still be the same. So let's assume that there is three brackets here. We're going to have something x. We're going to have something x plus or minus something. We're going to have something x plus or minus something, and then we're going to have something x plus or minus something. I know there has to be something in front of one of the x's at least, because we have a 2x cubed here. And when I do this x term times this x term times this x term, one of them has to have a 2 in front of it. Okay, I guess you could make the argument that we could have irrational numbers here technically, so we could have √2 and 1, but this is just GCSE maths, so so it's very likely that we're going to have a 2 in front of one of them, and then just a 1 here and a 1 here. Okay, now let's have a look at the last number here. This is more important. Okay, so forgetting about this first number for now, let's have a think about what these numbers have to be, because we have a 20 here, and these are all the constants. So we know that this constant times this constant times this constant is 20. So these numbers are going to be all the factors of 20. So let's have a think about all the factors of 20. 5, 4, 2, and 2. So these numbers could be 5, 2, and 2. Or -2, -2, and 5. Or 4, -1, -5. Okay, they're all the combinations that it could be. So let's think now about how that will affect it. So all we have to do now is try all of those different combinations. Okay, so let's list out all the possible factors of 20. We have -1, 1, 5, -5, 4, -4, 2, -2. There's obviously 10 and -10, and then 20 and -20. Okay, what we're going to do now is we're just going to try f of those numbers, because by the factor theorem, let's take this case for an example. Okay, if we find that f of -1 equals to 0, then we know that x plus 1 is a factor, and then we can work from there. Okay, and then we can divide that factor by this cubic, and then we can work from there. Okay, so what we're going to do is take an informed guess, and we're going to write all the factors of 20, both positive and negative, and we're going to substitute them all into our cubic and find which one results in a value of 0. And you should find that f of 5, this one here, results in a value of 0. Okay, so when you sub in f of 5, we get 0. So I hope that's a good explanation of what numbers you should try to substitute into your cubic to find a value of x such that f of x equals to 0. Once you've found a value of x such that f of x equals to 0, then you know by the factor theorem that x minus 5 is a factor, and you can literally write by the factor theorem x minus 5 is a factor. So now what we're going to do is we're going to find the other factors. 2x cubed minus 3x squared minus 39x plus 20. Okay, so imagine if I told you 2 is a factor of 4. How do you find the other factor? Well, you do 4 divided by 2, and that gives you 2, which is the other factor. We're going to do the same thing now. We know that x minus 5 is a factor because f of 5 equals to 0. Why did we choose 5? Well, 5 is a factor of 20. We know that one of the factors of 20 is going to be present here. That's why we checked 5, 1, 4, and 2, and 10. Okay, now we know that x minus 5 is a factor. Now we're going to divide it to find the other factors. Okay, so x, 2x squared, 2x squared. Okay, so to explain this, x times by something is equal to 2x cubed. That something is 2x squared. And then we continue the algorithm by doing 2x squared times by x is 2x cubed. 2x squared times it by minus 5 is minus 10x squared. And then we subtract these two terms from one another. 2x cubed minus 2x cubed is 0. Minus 3x squared minus 10x squared is 7x squared. This is something that a lot of people can trip up on. We are subtracting these two terms here. So this is minus 3x squared minus 10x squared. Okay, that's probably the only thing that could go wrong in these types of questions. Okay, once you get to this stage, you bring down the next term, minus 39x. and then you continue the same process. X times by something is 7x squared. This is 7x. And then you remultiply this 7x by x, which is 7x squared. And then 7x times by minus 5, which is minus 35x. Subtract 0, subtract these two, get minus 4x. Bring down the 20. X times by something is minus 4x, and that's minus 4. Minus 4 times by x is minus 4x. Minus 4 times by minus 5 is plus 20. Subtract 0. This is your remainder. Okay. So we know that x minus 5 is a factor, so we should get a remainder of 0 when we divide it. That's good. So now we know, if I just get a bit more space, going to rub this stuff out. So now I know that x minus 5 times by 2x squared plus 7x minus 4 equals to f of x. Now I'm nearly done. We could have a scenario now where the quadratic doesn't factorize. That can absolutely be the case. So they'll ask you to factorize, and this is where it will end. It won't go any further than this if the quadratic can't factorize. But in this case, you can factorize a quadratic, and it factorizes to two numbers at times to get minus 8 and add to get 1. Add to get 7 is going to be 8 and minus 1. So it is going to be 2x minus 1, x plus 4, x minus 5, 2x squared, yes. Okay, and now that's fully factorized. Let's say they asked us to solve, f of x equals to 0. So if they ask us to solve, they'll tell us to solve f of x equals to 0. And now we can just equate each bracket to 0 individually. We know x minus 5 equals 0, therefore x equals 5. 2x minus 1 equals 0, therefore, or x equals a half. And then we know x plus 4 equals 0. So we know x or x equals minus 4. 3 solutions there. So I hope that clears that up. Let's have a look at another type of question. Okay, so so this is another way to do it. I just thought I'd show you. So we are at this stage now. Let's pretend we've gotten to this stage. We know that f of 5 equals to 0. So we know that x minus 5. This is an alternative way to doing this long division if you don't like it. Okay, so we know now that x minus 5 times by something is equal to this f of x. Okay, this cubic here. Okay, if you just compare it to the old one, now we know that x minus 5 is a factor, so we know x minus 5 times by something should equal to this. How do we know what that something is? Well, if we have a think, there needs to be an x squared term here, right? Because x times by x squared is x cubed. So we know the highest degree term here, the term with the highest degree, is a squared. So we know this bracket is going to be a quadratic. So it's going to be in the form ax squared plus bx plus c. What we can do now is we can expand the brackets. This may be a little bit longer, but some people prefer it this way, okay? So let's have a look at expanding these brackets. This is going to result in x times by ax squared. So it's going to be, let's write it out here, ax cubed times by bx plus bx squared plus cx minus 5ax squared minus 5bx minus 5c. And that is in fact identical to, this means equals, but 3 means identical to. Again, it's not too important. Even in the textbook, they don't have the triple equal sign. So don't worry about it. You can write equals if you want. This is identical to 2x cubed minus 3x squared minus 39x plus 20. Okay, what I'm going to do now is I'm going to write these in different colors. So let's have a look now. A let's see, a x cubed plus b minus 5a times by x squared plus c minus 5b lots of x, and now I'm going to write this final term here, which is minus 5c. Okay, and that is equal to, in blue, 2 x cubed minus 3 x squared minus 39 x plus 20. And hopefully that long process is going to help us realize that the coefficient, so what we're going to do now is compare coefficients, and now we can realize that the coefficients of x cubed are the same, therefore a equals 2. And we can continue this same process here. So we know b minus 5a equals to minus 3, c minus to 5b equals to minus 39, and we know minus 5c equals to 20. And then we can solve for a, b, and c now, just some simultaneous equations. So that's just another way that we can solve a cubic. Or factorize a cubic. Once we get the values of a, b, and c, which will be exactly the same for the last question, we can just put them back into here. And okay, so let's have a look at another one here. So this is quite a tricky question from the textbook, the official textbook for the course. So here we have a constant of minus 1. So let's assume that there's 3 brackets here. So we have a constant term here, a constant term here, and a constant term here. Constant just means a real number. So we have a number times a number times a number is minus 1. So let's look at the factors of minus 1. It could be minus 1 or plus 1. Okay, and that's it. So when you compute f of 1, the answer is 6. When you compute f of negative 1, the answer is also 6. So you think, oh, wait a second. So now we don't know neither x plus 1 nor x minus 1 are factors. Neither of these are factors. Because we want it to if it turned out to be 0, that would imply that it's a factor. That's not the case. Okay, so we have a situation here where we know is a cubic that has roots, and we know at negative 1 the value is 6, and at positive 1 the value is also 6. But it has got a root. Okay, and it may well have a root between minus 1 and 1. Okay, so what we can do is we can start to try the numbers in between minus 1 and 1, and I promise you it won't get that far. It won't be something very obscure. It'll be a half or something like that. Okay, so what we're going to do is we're going to try half. Okay, we try f of a half, and that turns out to be 0. Okay, another way we can infer this is having a look at this leading coefficient here. Okay, so let's assume now, so we know that all of these are 1, 1, and 1. Some combination of positive and negative 1. Okay, so it could be 1, 1, and negative 1. Okay, and we also know that one of these numbers here, so we've got something x plus or minus 1. Let me rub this out, it's getting a little bit messy. So we're going to have, something, so we're going to have like ax plus or minus b, cx plus or minus d, and then ex plus or minus f. Okay, we know the values of b, d, and f. Okay, they're going to be either plus or minus 1, plus or minus 1, plus or minus 1. Some combination that will get, so that when you times them, you get negative 1. Okay, so let's just say it's minus 1, 1, and 1. We also know that 1 of A, C, or E has to be 2, because we know that A times C times E must be 2, because when we expand this, the cube term is going to be generated by these first 3 terms. So we know one of these has to be 2. So we know that at least one of the factors is going to be either 2x minus 1 or 2x plus 1. Okay, in which case we can try f of a half and f of minus a half. So I hope that makes the book explanation a little bit more clear. Okay, and it does turn out that f of a half equals to 0, and then that implies by the factor theorem that 2x minus 1 is a factor. Okay, and from there I'm sure you can continue and work in your own time to solve this equation. So you know 2x minus 1 is a factor. You can then divide it to find the corresponding quadratic and then solve that quadratic. Okay, so this turns out the solutions of this cubic are x equals a half or x equals minus 2 plus or minus the square root of 3. So you can try that in your own time. But I hope that clears up that last example. Just to finish off now, I just want to go through a couple of obscure examples. One, a little tip, when we are dividing a linear by another linear, let's say 3x plus 10, a quick way we can do this. So we know that this is 3x. Well, in this scenario, when we're dividing a linear by a linear that have the same like leading coefficient, x plus 1 divided by x plus 10, for example, what we can do is that we know this is the same as x plus 10 divided by x plus 1. What we can do is we can write this as x plus 1 plus 9 divided by x plus 1. It's exactly the same thing. And this is the same as x plus 1 over x plus 1 plus 9 over x plus 1, which is the same as 1 plus 9 over x plus 1. So we know the answer to this is 1 remainder 9. So that's just a quick way to do more simple questions. Just a little algebra trick here. If the top is very similar to the bottom, we can express this as x plus 1 plus 9, and then because these two fractions here have the same denominator, write them separately like that. You may or may not encounter that. That's just a small tip. And just to finish off, let's have a look at a type of question where we are doing something like this: x plus 1 divided by a cubic. Let's say x cubed plus x minus 5, for example. Okay, so let's try some polynomial division. Let's do this here. So x times by something is x cubed. Well, that something must be x squared. X squared times by x is x cubed. X squared times by 1 is x squared. And now we run into a problem, because x take away x squared we can't do. We could continue to write this out, but it will get very messy. So this is going to be x minus x squared, and now we'll bring down the minus 5, and now x times by something is this. It's just going to get quite messy, and the numbers can be much harder. So we need to take a lot of caution when we're approaching these questions. The example I like to give is let's look at a separate example. Let's look at a number. Okay, let's look at the number 1001. Okay, zeros don't mean anything. Zeros mean nothing. So why don't we just write this number as 11? Well, the reason is because the base 10 number system that we use shows us that this is 1000, 0 hundreds, 0 tens, and 1 1. So we absolutely cannot write this as 11. So we must take the same caution here. Okay, so this question was x cubed plus x squared minus 5, I believe. Excuse me, no, it was x cubed plus x minus 5. if there's no x squared term, we must write that 0x squared term here. Now this will work. Okay, so if we have a polynomial that has a term missing, we must write in that zero term here, just like in the case of this example here. So I hope that's cleared everything up, and I've given you a couple of different examples that you can try in your own time.